Hello students, this concept is again coming under unit 1 of computational mathematics, a very important problem for 5 marks. The population of a town in the decennial census, that means census which is carried out once in 10 years, was as given below. Estimate the population for the year 1895 using Newton's forward difference interpolation formula. So the information is given, year, that is x, and population in thousands. So you have to express the answer in thousands, remember. So that is y. That is given like this. So 1891 it is 46,000, 1901 it is 66,000, 1911 it is 81,000, 1921 93,000, 1931 it is 101,000. So what you do is you write it in the vertical table. So all x will come like this, y will come like this. Then the next column is delta, because we are using delta, delta square, delta cube, delta to the power 4 in the Newton's formula. So we require all those information. So this is delta, next is delta square, next is delta cube, and delta to the power 4. So here how to calculate delta? Now delta is the difference between the 66 and 46. So you get it as 20. So the next delta value here we got it as 15, that is 81 minus 66. Next it is 93 minus 81, that is 12. Then 101 minus 93, that is 8. So this is about delta. So in the next column you find delta square. So delta square is again the same method, but now this is 15 minus 20. So 15 minus 20 you get it as minus 5. Next is 12 minus 15, you get it as minus 3. Then 8 minus 12, that is minus 4. So this completes delta square. Next delta cube is the difference between these two, that is minus 3 minus of minus 5, that is minus 3 plus 5 it becomes, so that is 2. Next minus 4 minus of minus 3, so minus of minus becomes plus there, so minus 4 plus 3, you get the difference as minus 1. Okay, then last one is delta to the power 4. This is the difference between these two, that is minus 1 minus 2. So minus 1 minus 2 is minus 3. Now what we will require here in this problem, delta, delta square, delta cube, delta 4, is this one. See what is marked in the oval shaped here. So this is to be taken as delta, this is to be taken as delta square, so this has to be taken as delta cube, and this minus 3 to be taken as delta to the power 4. Other things are not required for us. So in the formula we have to calculate here P. So P is x minus x naught by h. Now what is this h? H is, see all those are equally spaced, 1891, 1901, what is the difference here? 10. So 1901, 1911, what is the difference? 10. So all are equidistant here. So H is the difference between this year and the next value, that is 10. So 1901 minus 1851, if you take, you will get 10. 1911 minus 1901, you get 10. So everywhere you take the difference, you get it as 10. So that is H. And then we require y naught. Y naught is this first value. See this one. 46 has to be taken as y naught. Then x naught is this first value of x. 1891. Then we require x. X means here, see, they have asked us to estimate the population for the year 1895. So where this 1895 will come? See, this is 1891, this is 1901, in between, right? So 1895 will come here. So that has to be taken as x. So calculate P. The formula here is x minus x naught by h. Okay, so substitute. X is 1895, x naught is 1891, h is 10. So you get it as 4 by 10 or 0.4. Now we will use the Newton's forward difference interpolation formula. Now 1895 lie in the upper part. You know that if it is lying in the upper part, you have to use the Newton's forward difference formula. And also in this problem, they have specifically mentioned that you are supposed to use Newton's forward difference formula. So the formula is like this: yn of x is equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 by 3 factorial into delta cube y naught plus p into p minus 1 into p minus 2 into p minus 3 by 4 factorial into delta to the power 4 y naught. Next is just a substitute. See, yn of x means y of 1895. This is what we are asked to calculate. So y naught is 46. P we have already calculated 0.4. Delta y naught is 20. So all those are directly substituted here, and you add all those values, you get 54.85 thousand. Okay, so this is the answer here. So this 1000 you have to write, otherwise you will be losing on mark, because the given population in the question is mentioned in 1000. So answer also should be expressed in 1000. Okay, so this is about Newton's forward difference interpolation formula. Next, let's see the similar problem, but only thing is we are asked to calculate for a different year. So this problem, you see, the population of a town in the decennial census was as given below. Estimate the population for the year 1925 using Newton's backward difference interpolation formula. So the table is given, x and y is given, same like the previous one. But now you see we are asked to find a population for the year 1925. See, 1925 comes here, 1921, 1931, in between is 1925. Okay, that is our x. Now h is found out same like a previous formula. That is difference between 1891 and 1901, the difference is 10. Again 1901 and 1911, difference is 10. So this difference also you will get 10, this difference also you will get here as 10. So h is to be taken as 10. Then here we require for backward difference interpolation formula not y naught, yn. So yn is this last one. The previous problem we wanted this y naught, it was taken as 46. Here it is yn, so 101. Okay, so calculate p using say the method here. P is equal to x minus xn by h. There is a slight change here, so you will get this as minus 0.6. You can get it as minus, no problem. So you have to substitute with minus sign only the value of p in the formula. Here the difference is also calculated in the same manner, but only thing is instead of delta, we write here, we call it as del. See, the symbol is inverted. So del square, del cube, del to the power 4. In the previous one where we calculated delta for the forward difference, we have used these values, right? Now you see for backward difference, we have to use these values when we use backward difference formula. See, 8 delta means 8, delta square means minus 4, delta cube means minus 1, delta to the power 4 means minus 3. Okay, so that is another change. Now come to the formula for backward difference. Now what change here is, in the previous one it was y naught, so here we change everywhere by yn. Okay, then another difference is, in the previous one it was p into p minus 1, so here it becomes plus. There also in the previous one it was p into p minus 1 into p plus 2. Wherever there is minus, we replace it with the plus sign here. So the formula is yn of x is equal to yn plus p into del yn plus p into p plus 1 by 2 factorial into del square yn plus p into p plus 1 into p plus 2 by 3 factorial into del cube yn plus p into p plus 1 into p plus 2 into p plus 3 by 4 factorial into del to the power 4 yn. Next you just substitute. See, yn of x is 1925. So yn is 101, p is minus 0.6, del yn is 8. So all those things are from the previous table. So you have to just substitute. That's all. And you know 2 factorial means 2 into 1. Okay, it is 2 only. 3 factorial means 3 into 2 into 1. 4 factorial means 4 into 3 into 2 into 1. So all those things can be easily simplified like this, and you add them, you get 96.84 thousand. Again you have to express the answer in thousands here because it is given in the question. The population is estimated in 1000. Okay, so thank you for watching. Now both of these problems are very important, so study them thoroughly. Thank you.